I'm Sean Prestridge, Senior Field Applications Engineer for Iar Systems, and I'd like to show you our new C-Stat static analysis tool. In order to enable C-Stat, you can take any project and go into the project options by right-clicking on it in the workspace window. You'll notice that there is a new category for static analysis. You can see what C-Stat options are available by clicking the Select C-Stat checks. You'll notice that there are MISRA 2004 as well as 2012 rule sets, as well as MISRA C++ 2008. I'm going to take a look at just some of the standard checks that we can do with C-Stat, and you can see that there are quite a few different things that are available to us. What I'm going to do is to analyze the project that I have open and see what kinds of errors are detected and see what I can do to correct them. If I compile my code, you'll notice that what happens is I get a very quick analysis that I get from the compiler, but it compiles with 0 errors and 0 warnings. In order to analyze it with C-Stat, I can right-click the project and go to C-Stat and tell it to analyze the project. This will take just a few seconds to complete for my project, but you can see that there are quite a few errors that are caught by C-Stat. The first one I can go to by simply double-clicking the warning message that I see. In this particular case, it tells me that the mod function can actually return a negative number, which obviously isn't within the framework of what you can do with the shift operator. There's a very simple fix that I can do with this simply by invoking the absolute function. What I can do is create an unsigned integer that's called my IRQ, and I can set this equal to the absolute value of IRQ modded by 32. Once I do this, I can change my entry value in here from IRQ mod 32 to my IRQ, and if I do my analysis again, I can go ahead and do it on my entire project. You'll see that the error message disappears for that particular line of code. So as you can see, I have several different errors within this function that are essentially the same thing. I can go through that particular piece of source code and eliminate all those errors. But let's take a look at some of the other errors that are detected by this. If I double click this error, you can quickly see that although I'm assigning variables to a temporary, or I'm assigning values to a temporary variable called temp_reg, you can see that right here, even though I do an and equal, I then assign it to another value completely, which thus obviates what I'm doing in the previous two statements. So this may be what I intended, or there may be some volatile action that's going on that I want to be preserved, but it's an indicator that perhaps I didn't finish coding this particular section of code. So it points it out as something that I need to analyze a bit more closely to see what's going on. Again, if I scroll through this particular piece of source, you can see that there are several instances where I did this. Scrolling down and taking a look at some of the other things that I have available. Inside of here, I have another error message which tells me that if I implicitly convert my variable C to an unsigned 32-bit int, that I can actually get a range for my overall calculation that may not be what I intended. Now, of course, the implicit conversion to unsigned int may be what I intended, but to make it clearer for people who will be maintaining the code, what we can do is do an explicit cast to an unsigned int. Once I have it as an explicit cast, then what I can do is I can go through and I can reanalyze my project through C-Stat static analysis, and what I'll see is that this particular error or warning message from C-Stat goes away. Additionally, what I can do is take a look at some of the other error messages or warnings that are assigned to me. Again, if I go into standardlib.c, you can see that there's another instance here where I have a range error that could be happening, and I can use exactly the same technique that I did on the first file, where I can use an absolute function to be able to get around it. So this makes the behavior that I want the compiler to take explicit, and it also shows anyone who's reviewing my code what my intention is for the software that I've created. If I go down into my last set of error messages that I received from uart.c, you can see that I have kind of a similar instance where I could have an overflow condition. By using a similar technique, I can make sure that I explicitly identify to the compiler that this is indeed what I wanted to have happen. So as you can see, even though the compiler does help you to find certain errors within your code when it does the compilation and issues warning messages, there are quite a few rules that you can put into it with a coding standard by using C-Stat that can help you to avoid other potential error sources and thus reduce the number of errors that you have in your code when it goes out for formalized testing, and also make sure that you don't have those kinds of errors when your product is released. So thank you for watching this video, and I hope you found it useful.